Good morning, children. So we'll start right off from where we stopped in the previous video. So until now, we have covered what is current, which is the rate of flow of charges. Under that, we have two formulas: is Q is equal to N into E, and E value, N value are found, and we found what is current, which is I is equal to Q divided by time. As unit of current is ampere. Then we had voltage. And what is this voltage? It's a source of potential difference. It's a battery. So because of this potential difference, the charges are able to move from one point to another point, and this movement produces current. And we have seen about two types of current. One is your conventional current, which is from positive to negative. It does not exist in real life. Next is your electronic actual current, which goes from negative to positive. So, and potential difference unit is given as again voltage, and voltage is equals to work done by charges. That is whatever work you do in carrying a charge from one point to another point. So this is what we have seen until now. And before ending the video, I told you to imagine a thought experiment related to my brother, what he did, right? He met with a electrical accident when he tried to insert a motor directly into the socket to make it fly, and it just threw the motor away, and he also fell down with a shock. So the thought experiment was, take up a small bulb, connect to a small battery, bulb will glow. Connect to a bigger battery, it will go brighter. Connect to the double side battery, what will happen? It will be even more brighter, the bulb would become warmer. If you directly plug into the socket, the bulb will burst. So what is happening here? What two quantities are being related here is the thought experiment. Clear? Or you could even think in terms of fan speed also. So increase, let's say you connect a better battery. As you increase the battery, the motor would spin faster, or control the fan will become faster. Why is this happening, and what two quantities are being related here? Please think about it. And the two quantities that are being related here are voltage and currents. Clear? So as you increase the voltage, the current is increasing. As you decrease the voltage, the current is decreasing. Why? Because what is voltage? Work done by charge. So as I increase the voltage, the current should what? Increase. So this law, what we'll be learning in this class, is based on this proportion that V is proportional to I, and this is given by a person called George Simon Ohm. And by now you must be guessing the law. Yes, this law is called as Ohm's law, and according to this law, if voltage is more, current is more. If voltage is less, current is less. Clear? So to visualize this more better, we will see a simulation for this concept in the PHET website. It's an educational website, open source website. Anyone can make use of it and learn it. I have attached a video right now on how to use simulation, build a circuit for learning this Ohm's law, right? Yeah, children. So this is the website that I've been telling about. PHET Colorado University's open platform to visualize and learn various concepts of science, math, and geology. Okay, so once you just type PHET in your browser, it can be either Safari, Chrome, whatever it is. The first link will open up to this page. Then head on to physics. After heading on to physics, you can give filters on the topic. Right now, since we're dealing about Ohm's law, we have to specifically deal about current electricity. So you can give current electricity or electricity magnets here. Out of this, please go for DC construction lab. Why DC construction lab? Because we are dealing with direct current. Direct current is just only one direction. Example is your battery. So in all these examples that I'm dealing so far, we are using battery as a potential difference source, right? It has only one direction of current. This is called as DC, right? So what is Ohm's law? As you increase voltage, current has to increase. So I'll construct a basic kit right now. So this construction circuit is based on your CBSE activity number 1. The same activity is present under various names and numbers and across various syllabuses. Activity is quite simple. You just build a small circuit and see how the current value changes as you change the voltage. So to build a circuit, I'll just take our battery first, connect a wire. I'll just use a single bulb because our aim is here to establish a relationship between current and voltage. I'll use ammeter. As I told earlier, ammeter must be in series. What is series and parallel, we'll be learning in the upcoming classes. Next is the connecting thing. Current value showing as 0. Next, I'll use a small switch to open and close it. Switch, I'll connect the junction here. Next, along with this, let me also use a voltmeter. Negative to the negative terminal, positive to the positive terminal. Okay, so when I turn on the switch, the current is flowing. What you see is a flow of electrons go from negative terminal to the positive terminal, we know it, but conventionally the current direction is taken as positive to negative, which is because of Benjamin Franklin. We learned in last class. Is the current actually in this direction? No, we just take this direction, the flow of opposite to the electrons. Clear? Now when I do this, current is flowing, switch is closed, it's fine. See the voltmeter reading, the voltmeter is connected parallel, and the voltmeter reading is showing as 9 volts, and the current reading is showing as 0.9 amps. So according to this concept, just note it down. Take a small tabular column, take first serial number, under serial number 1, first write the current value as 0. First write the voltage value as 9, and then current value as 0.9. Then make a third column, divide V by I. When you divide V by I, it's basically 9 by 0.9. 9 by 0.9 will give you 10. Okay, just note it down. Next, what I'll do, I'll disconnect the circuits, and in the same junction I'll add one more battery. So if I add one more battery, what result is expected? Yeah, the result has already come. What is happening? The bulb is glowing much more brighter than how it was earlier, and see the readings now. The voltmeter reading, it's showing 0 because it's not connected. The voltmeter reading is 18 volts because I'm using two batteries of 9 volts each. So 9 plus 9 becomes 18. When the current when the voltage is 18, the current became 1.8. Earlier it was 9 and 0.9. Now it is 18 and 1.8. Again apply the same logic. Under serial number, write serial number 2. Write the voltage as 18 and write current as 1.8. And 18 by 1.8 will give you 10 again. And what do you observe here? What pattern do you observe? As you increase the voltage by 2 times, current also increased by 2 times. 9 2s are 18, 0.92s are 1.8, right? So we'll take one more reading, nothing wrong in it, right? So I'll just cut off the junction, add another battery. So what's happening now? The potential difference is, yeah, you guessed it right, it must be 27 because you have used 3 batteries of 9 volts each. Potential difference is 27. And what current do you observe? You see a current of 2.7 amps. Current also increased by 3 times. As you increase the voltage by 3 times, current also increased by 3 times. Or you can even visualize the thing. Which one? How beautiful the bulb looks. It just keeps on getting brighter and brighter as you increase the voltage. So we can indirectly establish a relationship that as I increase the voltage, current is increasing. As simple as that. We can relate this to the example I told earlier. Take a small battery, small bulb, bulb will glow. Take a bigger battery, it will go brighter. Much bigger battery, it will become warm also. Put into the socket, the bulb will burst. Why is happening? Why is this happening? Because as you increase voltage, current is increasing. That's it. And whenever you divided V by I, did we get a different value or same value? Think and tell me. We got the same value, right? Earlier it was 9 by 0.9. Next it was 18 by 0.8. Next is was 27 by 2.7. We all got the values of 10, 10, 10, right? That 10 is called as resistance of the bulb. That 10 is called as resistance of the bulb. So here you are mathematically right. The resistance of the bulb is given as 10 ohms because the SI of resistance is ohms. So what is this resistance? What is this quantity? We'll see in the derivation that I'll be writing right now. Clear? So in the upcoming derivation, we will establish the relationship between V and I according to ohm, and we'll tell one of the consequence of this derivation is what we have another quantity called as resistance. Clear? I hope it is fine. We'll end the simulation as of now. Please try it by yourself once. It will be very helpful for your understanding part. With the advent of competency based questions in the paper, this building of circuit will go handy for you to attempt and score better. I hope the video was understandable. Okay. I hope the simulation made things very clear. As I increased the number of batteries, the current value kept on increasing. For example, I hope you all made the tableau column, right? You had serial number here, and you had voltage here, and you had current here. So talking about your serial number, we had 2 3 readings, wherein the first reading was 9 volts, 0.9 amps. Second reading is 18 watts and 1.8 amps. Third reading was 27 volts and 2.7 amps of current. And what was the third column? I told take V by I, right? So it all came 10, 10 and 10. So when you take V by I, it's always coming to a constant. That is what he tried to tell us. Clear? So according to this derivation, if you take up V is proportional to I, then V by I must be equal to some sort of constant. And what constant did we see? We saw the constant as V by I is equal to R. That constant is called as resistance. So if I could rearrange this as V is equal to IR. You should never forget that. V is equal to IR, not I plus R, I by R, I minus R, R by I, nothing, plain. V is equal to IR. You know V is proportional to I, and remove the proportionality, introduce a constant which is your resistance. So here this V by I was nothing but what? Resistance, and the resistance was constantly how many ohms? 10 ohms. But none of these would be called as Ohm's law, as I told earlier, if you do not mention the condition. What is the condition? First condition is temperature, and second condition is all physical conditions. Only when these two conditions are constant, then Ohm's law is applicable. That's it. So if they ask you about Ohm's law, just remember V is proportional to I, and the mathematical representation is V is equal to IR. So how do you put into general terms in terms of exam? The current passing between two ends of the conductor is directly proportional to the applied potential difference, given that the temperature and physical conditions are constants. That's it. Now, how would you do this in terms of a graph? So we'll look more into the concept of graphical representation of the same. So I'll take up a VI graph, which is voltage and current here. This is just introduction. We have the next class only about graphs and resistance. That class will deal deeper about it. Right now, to match up with this concept, we need to learn a small basic graph. And the current values are given as what? 0.9, 1.8 and 2.7. Let's say I'm marking them here roughly, and I'm marking the voltage values here. If I could plot anyone, we'll be able to make it out easily that I'll be getting a straight line. Clear? So if you get a straight line like this, or roughly straight line, that line is called as that material for which you did the activity. That material is called as ohmic conductor, because that straight line represents that R is equal to a constant. That means that that conductor obeys Ohm's law. Clear? Now basically, what is the formula for slope, children? The formula for slope is given as delta y by delta x, which is y2 minus y1 by x2 minus x1, which is basically change in voltage axis by change in current axis. which would give you resistance. So resistance can also be found using the graph. Take voltage, take current, divide voltage by current. For the slope, it's done. I hope it is clear now. So in today's class, we have seen about Ohm's law, made very simple for your understanding. That is, V is proportional to I. So V by I is equal to R. So V is equals to IR. So what is this resistance now? So resistance also will be given in introduction today, but more about this resistance and the types of graph we'll be seeing in the upcoming classes. So talking about your resistance, all of you just remember this one term. That term is obstruction. The term that you guys have to remember is obstruction. So under resistance, the term you have to remember is obstruction. So resistance is something that's trying to stop. What is it stopping? It is stopping the current. That is why when you rewrite V by I is equal to R at constant voltage, I and R are inversely proportional. So what causes this resistance? If you've seen our previous classes, we have seen about the conductor, right? Structure of a conductor. In the conductor, we have electrons, other electrons. If you just take up 1 coulomb also, we have 6.25 10 to the power 18. Similarly, the same number you will have a number of protons also. So the path itself is going to be very congested from one point to the other point. So when you're going from one point to another point, it won't be an easy task. You'll have a lot of blockage where you'll be repelled by another electron or you'll be attracted by another proton. A lot of collisions will be there, forces will be acting on, because of which you will feel a lot of hindrance. This hindrance that you feel when you go from one point to another point because of other factors is called as resistance. Clear? Obviously resistance is stopping the current, that is why they both are inversely proportional, and since it is a, what to say, extension of Ohm's law, this unit of resistance is given as ohm and omega as a symbol. The unit is given as ohm and omega as a symbol. So if you want to rewrite in terms of ohm, you can write it as 1 volt by 1 ampere is equals to 1 ohm. That is, if you pass exactly 1 amp of current between 2 points of the wire, or you can tell when the voltage between the 2 points of the wire is given as 1 volt, and if exactly 1 amp of current is passing, then the resistance given here is given as 1 ohm. Clear? This is the introduction that you need about resistance. More about resistances, that is your variable resistance, VI graph, IV graph, and factors affecting resistance, we'll make a separate video. That video will be for like around 45 minutes because it is one concept prolonging and where the major weightage or major chunk of marks goes for. So that will be a separate video. But this video, since resistance is an extension of Ohm's law, we had to give the introduction. I hope it is clear now. So in today's video, we have seen about Ohm's law, that is V is proportional to I, V by I is equal to R, R and I are inversely proportional. And then we saw VI graph, where you find the slope of VI graph, we'll get the resistance. So we'll just do one or two basic sums and we'll run up for the day. First is, let us assume that it's going to be very simple. Sample sum number 1. So you'll be using only this law in all circuits. This is like the central part of your electricity. With this central part, you will relate your previous charges topic and the upcoming series parallel power energy concept. Without this central junction, you cannot proceed further nor go backward. So this is central junction and this is very important in terms of physics for electricity in this board perspective. So let us say there is around 2 amps of current passing when you apply a potential difference of 4 volts. So what is the resistance? Piece of cake is going to be V by I. So it's 4 by 2. Answer is 2 ohms. As simple as that. For example, second case, let me assume that for a wire of resistance R, when you apply a potential difference of 10 volts, the current passing is 5 amps. When you increase the voltage to 20 volts, what will be the new current? V is the old voltage for which the current is 5 amps. V dash is the new voltage 20 volt. What will be the new current is the question. You got my point? We have a wire here. In this wire, what is the potential difference? First, the potential difference is 10 volt. Then how much current is passing? 5 amps of current is passing. For the same wire, if I give 20 volt, how much current will pass is the question. Clear? Now there are two methods. First method is find the resistance, apply it here. Simple. So resistance is equal to V by I. So it's going to be 10 by 5, which is 2 ohm. Apply this here. So it's going to be I is equal to V by R. That is new current is new voltage by new resistance. There is no thing as new resistance or old resistance. It is going to remain the same because this wire has certain resistance R. It's going to remain the same. See, there are certain factors resistance depend upon, like temperature, which will increase with respect to time. That is much more complex to think about, which comes after like 3/4 of a chapter. Right now that is not required. Even in the exam perspective, those questions will not be coming for your CBSE, where the resistance and temperature dependence that does not come, so don't have to worry about it. So this wire has a resistance of R, so no matter what, it will have a resistance of R. That's it. Clear? So here the resistance is 2 ohm. So whether you pass 10 volt or 20 volt, the resistance is going to be 2 ohms only. The same logic has to be applied in your power concepts also. So using the same thing, I can write that I is equal to V dash by R, and V dash is 20 divided by the R is 2. The current is given as 10 amps. This is one way of solving, where you first find the R and apply that R here. Other way is very simple. It's like a mental concept. What did we learn? If the resistance is constant, as you increase the voltage, current should increase, right? You remember the previous concept? 9 to 18 two times, so 0.9 became 1.8. Similarly, voltage was 10, increased to 20. Current is 5. So how many times is the difference? 10 into 2 will give you 20, right? Similarly, you have 5 amps. 5 amps into 2 will give you the new current no matter what. So the new current will also be equal to 2 times the old current. How do you know that? Because the new voltage was 2 times the old voltage. Applying that, I can take the new current as 2 times the old current. The answer will be 10 volts, 10 amps. Clear, children? Very simple. So starting from now on, there is no such thing like you have to follow one specific method to solve the sums. You're open to solve by yourselves. You can put in your innovation according to the scenario. But only one thing you have to remember, something fundamental is Ohm's law. It will be applied in all the circuits starting from now on. It will relate directly to I is equal to QT and V is equals to W by Q. Clear? So we'll wind up with one more simulation that shows about Ohm's law. Before that, I created a small simulation using ChatGPT, wherein you can apply the voltage and current readings and see how much resistance is changing, or you can change the resistance and voltage and see how much current is changing. So we'll see that simulation in ChatGPT first, then we'll go for the PHET simulation about Ohm's law and wind up for the day. Clear? Thank you for watching, children. Thank you for your patience. Okay, children, to finally wind up with a small recap, I have brought another simulation for Ohm's law. The same thing is present in your PHET website. It is given as Ohm's law verification itself directly. It doesn't involve any sort of building the circuit, rather, you can just verify Ohm's law. So, see the resistance here. Resistance here is given as 500 ohms. The current passing is 9, small m stands for milliamps, and the voltage is 4.5 volts. And what did we learn? Keep the resistance and constant. So instead of keeping it as 100, I'll just reduce a little bit. I'll keep the resistance somewhere in the 222. The resistance is 222 ohms. I'll just fix it as it is. Now we just see the variation of current with respect to voltage. As I increase the voltage, current is increasing. As I decrease the voltage, current is decreasing. As simple as that. As I increase voltage, current is decreasing. As I decrease voltage, current is decreasing. As I increase, it is also increasing. Clear? Now, always remember, current depends on voltage and not the vice versa. The vice versa is not physically possible. You control the voltage, you design the number of batteries or input. Based on that, the current value will change. By controlling current, you cannot control the voltage. Please keep it in mind. By controlling current, you can't control the voltage. Maybe you can assess it or guess it, that's it. But by controlling voltage, you can control the current. That is why if you see the simulation, do you have any sort of control for current? No, because the current depends on voltage. Apart from current depending on voltage, let's say I keep the voltage constant. It's 5.7. The voltage is kept, not touching the voltage again. I keep the voltage as constant. What will happen if I increase or decrease resistance? What will happen if I increase or decrease resistance? So if you rearrange the equation as we learned earlier, we got the formula for resistance as V by I, right? So I and R are inversely proportional. So as I increase the resistance, current should decrease. As I decrease the resistance, current should increase. Is it clear? Because they both are inversely proportional. And basically, what is resistance? Resistance is the obstruction to the flow of current. Current is just flow of charges, so they both must be opposite to each other, right? So mathematically and physically, this is the understanding between them. As you increase resistance, current is decreasing. As you decrease resistance, current is increasing. The dots you find is the number of collisions with the other protons or other electrons in the circuits, the wire. That's it. So we'll wind up for the day. This is a relationship between voltage and current given by Ohm, George Simon Ohm. But it would not be George Simon Ohm's law, it will be your law unless you don't mention the conditions. And the conditions are temperature and physical conditions to be constants. Do not forget this. Okay? Because based on the temperature and physical condition, the resistance will vary from place to place. If the resistance is varying from place to place, it means that the V by I ratio is changing from place to place. Then it's not a constant. So it is not a law. Is it clear? So whenever mentioning the law, please ensure that you are also mentioning that the temperature and physical conditions are constants. So in the upcoming class, I want you to find out one major thing. That is, what is the relationship between the temperature and resistance, and what could be the other factors the resistance would depend upon. And we'll go all about resistance, factors affecting resistance in the upcoming class. Thank you. Okay, children. So I hope the concept is clear. We have used simulations and some theoretical understanding to get it right. So for now, let's keep it right. Just be clear about Ohm's law. It's more than enough. And in the upcoming classes, we will be studying about what is resistance, VI graph, IV graph, and factors affecting resistance. It will be extensive class, but in that one class, we'll be covering everything about resistance. If the resistance doesn't fit in, then we'll have a part 2 for resistance, which will comprise of factors affecting resistance in the upcoming classes. Thank you so much for your patience. Happy learning. Keep learning. Thank you.